back and
Hello.
Yeah,
I think
Anurag,
maybe
yeah,
Victor might have hit the wrong button.
oh yeah, he might have declined the recording.
Okay, wait, I don't know how I pause the recording here.
Okay, that's what crashed on me last time. I'm still here though. So I thought it would be interesting to go back and take a look at a little bit of the stuff I developed earlier in the project and have used for various testing purposes since, but I haven't built the sort of bigger feedback loop incorporating it that I've wanted to and been intending to for a long time. And that is with Docker. Now, Docker is part of an attempt to answer the general question of how you develop software and get it working in locations other than the one it was developed in successfully enough, for some value of successfully enough. The bar on that in general keeps moving. It turns out to be complex, and Docker is an attempt to address it in what looks like, if you're using it for a basic case, as simple a way as possible. So the overall stuff I'll go over is, what is Docker? Where can you use it? What can you use it for? And what problems does it address, or at least attempt to address? A little bit on the architecture, where input comes from, what the Docker daemon on a local host or on a local system looks like, and how containers, images, and registries fit into that. I'm going to give some example Docker files, Docker Compose files, and so on for a desktop environment that can run locally or in Kubernetes, and for running software deployments on a Raspberry Pi. And when I'm doing that, I'll go over the workflows. So this is going to be looking at the files and examples of running things as part of this. So it won't just be entirely abstract, though will be examples of things being done. And I'm also very curious about and would love to have a discussion about how people are managing software and firmware deployments on rovers. So as far as an overview of Docker, Docker's virtualization software, assuming most people are familiar with virtualization in from one way or another that they use it. And the primary use case isn't running a full operating system, it's running a single application. And the application in most cases runs in a container. In some cases, it runs in a lightweight VM. The container or VM includes the application, all of the application's dependencies, and for an added bonus, the rest of an entire Linux operating system. And where can you use it? Well, there's a native Docker application now that runs on Linux, Mac, and Windows. Each one of these has a different background implementation. The Linux level is OS level virtualization. So what that means is whatever kernel is on that Linux system, the host system that you're running, that kernel will also be running inside of the container. That's the traditional way that containers have been done before Docker, that they're basically a way to encapsulate a lot of resources. The old school way of doing this, you would actually run an entire operating system in a container. It would just be isolated from the operating system using mechanisms that were potentially built into the kernel or potentially custom built in some other way. And implementation on Mac and Windows is a lightweight virtual machine. It still looks the same and acts the same for most purposes. In fact, basically all the purposes that you would get as far as using it. Like the command line is the same on them. Only when you got into gory details of how the backend files are stored or something like that, which you don't normally have to do as an ordinary user of it, would you have to care very much that it was running on a Mac or it was running on Windows. Once you get to that point, you know that you've actually been using it enough to develop a relatively complex use case, and not just the generic ones that you run into initially. It does support different architectures. It supports x86, ARM, and I believe actually IBM S390. Kubernetes can use container images that are created by Docker. They can conform to a particular standard called the Container Runtime Initiative Standard. It used to be that that Kubernetes used Docker directly, at least the Docker's runtime. But at this point, Docker has dissociated itself from that, and Docker images can be used, but Docker and Kubernetes aren't so tightly intertwined together as they used to be even a year ago. Things that I've seen it used for, it's very widely used for developing locally and deploying to cloud environments. The same image can be used in both locations. How many of you are familiar with the variations on the it works on my laptop problem? So in other words, that's when you write some software somewhere and you've set up the environment and it always works right for you. And then when someone else tries to take that software and use it in some other environment, it doesn't work for them. So Docker is a pretty good way of addressing that particular issue. And that is still widespread. I still run across developers who are, for example, developing locally on a Windows system directly and committing code that will never work in the production Linux environment due to differences in lines and configuration files and things like that. It is also helpful in making research more reproducible. I would say it's actually more for making the assumptions more visible. If someone provides the code for their research, plus a Docker file to build the image, plus their data, then you can examine everything that went into that process, rebuild it, and rerun it yourself. And that's useful. It's not necessarily completely reproducible because maybe by the time you take a look at it 6 months or 2 years later, the operating system level dependencies have changed. And so when the Docker, you fire up the Docker image and the first thing you build the image yourself, and the first thing that happens is an apt-get update and an apt-get dist upgrade, you're not getting the same versions of the packages that the person got 2 years ago. But you can at least see what they were doing. And that's actually a fairly big step up from the default. Some conferences do require artifact evaluation as part of the review process, and you would provide exactly those things, maybe not data, depending on the conference. And one of the reviewers, not necessarily the same reviewers who review the paper part, would be reviewing your artifact and seeing if your claims match what your code actually does. Then it's also fairly widely used on internal corporate clusters where they need support for multiple operating systems and multiple versions of software. It isn't great for HPC per se. The security model in HPC is that all of the users who are using the cluster do not have administrative privileges on any systems in the cluster. Docker, it's fairly hard to keep on an HPC cluster anyway. It's fairly hard to avoid escalation routes to administrative privileges if people are running Docker there. It's also, what I'm using it for is application deployment on single board computers like my Raspberry Pi. And so it's got a pretty broad range of uses that, you actually know people who are doing these things, all right? But it's like, why is Docker? So Rhett had a very good question about software, which is, when you're looking at a piece of software, you should ask who hurt you. And that's a pretty good indicator of why this thing exists. Before Docker, these problems existed. After Docker, they still exist to some extent, but it did actually go a fair ways towards addressing them. Development environments were often custom built and ran on developer laptops. Code would work fine in the development environment, fail in the production environment, and they'd be different. And testing and checklists were a way that people tried to handle this for a very long time. That has never proved to be sufficient. It's also incredibly high overhead and very prone to errors of various sorts. And full virtual machines used in production, they did have higher complexity, inherent complexity, and high resource utilization, since you were dealing with a lot more than just the operating system. And the operating system itself might be consuming a lot of resources. And the other part of this was more structural, organizational than it was the actual technology. The system administrators tended to be in charge of the systems, and they were more concerned with not having things break and what those gosh darn developers were up to when they would deploy code that would break over and over again. And so they put up a lot of barriers against changing things. That meant that overall, deploying new code was not that frequent, pretty risky, like you'd have all hands on deck for it. And then you'd also get, the sysadmins pointing their fingers at the developers and the developers pointing their fingers at the sysadmins when things went wrong. Docker addressed that by both technical and non-technical approaches. Here's some of the top ones. They said, foo on this whole operating system thing. That's the domain of the system administrators. We're just going to run the application that we actually care about. So if you look inside a Docker container, nothing is running but the application. There's no system services. If you were to look on a regular Linux system nowadays, like a desktop system, you might see 200 processes running. Docker container, if you were to examine it without actually entering it, you would see the application running plus whatever processes the application spawned. It does, at least compared to virtual machines, reduce the resource utilization per instance of the application using containers. And you can use the same images in development and production. So in other words, what I use on my laptop, I can use somewhere else under most circumstances. And what makes it neat is that automating the whole pipeline is possible. Building the images, deploying them, testing them, all that can be completely automated and is by default entirely under version control. That is also very different from having people do things manually. It is susceptible to complete automation. And it is pretty much a de facto standard to do that now. Overall, this approach does reduce the time to deployment. And if it's sort of put in the right organizational context, it does make sure that the incentives of the people doing development and operations are more aligned. DevOps and SRE both help with that as a way of sort of organizing and structuring that and giving it a kind of a culture and a context. But overall, those things come together on top of Docker and a few other technologies that sort of shifted things over and away from the world of pure system administration more into things where the development was more in charge of what happened as far as deployment. As far as the architecture, you're talking about if this is running on your system, this is what it looks like. It doesn't look the same on Kubernetes. The input is from a command line or a GUI. Almost everybody I know uses a command line who uses it. You are running individual commands like building an image, pushing it to an image repository, pulling an image from a repository, running the container, or running a command inside of a running container. Those are the basic, or some of the basic commands. There's actually a lot of potential options. If this is your laptop, you're the host, your system is the host running a Docker daemon, and it manages containers and images. Containers can be running or they can be stopped. Those are their two primary states. And the images are stored in a local cache. So you could have 5 containers running the same basic image. You could have multiple images, multiple containers. If you do this a lot, your system will fill up eventually. Even just during this project here, I think I've had my disk fill up several times, but I've been doing a lot of, build, pull, so on. And what makes this kind of neat as an approach is that either at your company or on Docker Hub or some other large repository, but Docker Hub is the largest, you can download images that other people have created. So if you were interested in a piece of software, it's fairly common that the developers of that software will have created a Docker image on Docker Hub for you to download and try things out. So you don't have to worry so much about installing it from scratch. You maybe, in the simpler cases, you just get the software running in an operating, in an environment that's good for it, like things that work best on Ubuntu 18.04 build. They'll provide an Ubuntu 18.04 image. And in more complex cases, you might get something where you set up an entire network of virtual machines to test some big piece of software. So the architecture is relatively straightforward. Once you've taken a look at it a little bit, there's some details when we start looking at the images themselves and seeing how those are built and so on. I figured it would be useful to actually go into the Docker files I'm using right now. And so I was going to go through those, plus actually running stuff on both Kubernetes and on the PyCar and getting them to talk to each other. So a little bit of context for this up front is that when you're dealing with operating systems and software, there's a lot of yak shaving. If you aren't shaving the yak, someone else is. So, and if they aren't shaving the yak either, then at some point things are either going to stop making sense or they're going to explode. So the examples I've got cover several different ways to run Docker, like through Docker Compose, through Docker directly, and through Kubernetes. I don't make these the most efficient possible. I did not hide the complexity. And I, in fact, sometimes bring it out to the surface so you can see what's going on. This is more for learning than it is for efficiency. If it was a production environment, not everything in these files would be the same as what I'm doing. I'll try to mention those where it's relevant. Also, since we've got a lot of people with different backgrounds here, if you see something where there's a cool alternative approach to any particular thing that I'm doing or a tool that might be relevant, then speak up. So I'll share, doesn't look like I can share. Okay, so did that switch tabs in the sharing? No, or it did? Okay,
Yep.
Good. All right, in that case, I'm going to switch over to here. So PyCar Docker is the repository for building Docker images that work on the PyCar itself, on a Raspberry Pi. And so this stuff, I actually build the images on my laptop, and it is not an ARM architecture. So I build those on my laptop, push them to Docker Hub, and then download them from there onto the PyCar. And so the first question is, where's most of the complexity? Well, most of the complexity is in the Docker Compose specification, because, or at least most of the complexity in running things is in the Docker Compose specification, because you can see all these commands here. They're pretty much the same command over and over with just a different suffix on it, like removing a container that I already have on the laptop, doing a build of the container, building the container with no cache because sometimes the cache information is bad, pushing it to Docker Hub, running it, stopping it, and I think I already did the build. So this is a short, uncommented specification. This image is remote. So when I do a Docker push, the default for this is going to put it out to Docker Hub, push it out to Docker Hub. Also, I'm building for an ARM64 platform. When I run this on the PyCar, I want it to run at all times. So if the image is off and I reboot the PyCar, this will start up again. Since I'm running a VPN, then normally this container would not be allowed to access things on the host system. However, here, in order to get the VPN working, I've got to add the netadmin capability under Linux on the host system to be accessible from within the container. So that's why you see that there. As far as the devices, these are the exact devices that the software that is running in the container needs to access on the Linux system in order to be able to control the hardware on the system. If the hardware on the PyCar were more complex, you would see more devices here. As it is, I need general purpose IO, and I need I2C devices. Then I map a home directory that is persistent because the containers themselves are not persistent. Yes, Meyer?
Yeah, how do you know what the devices and capabilities are?
So that was done by experimentation. So in other words, I had to look at the software that was initially provided by the vendor and reverse engineer which devices it needed access to, and then do that. If I hadn't had their software, I would have taken a look at the manual, figured out how on the Raspberry Pi, I set pins high and low on individual ports. And then I would have made those devices available. First, I would have tested directly on the operating system on the Raspberry Pi. Once that worked, I would have made those devices available inside of the container. So yeah.
There's no way for some sort of debugger of the container to tell you, well, he wanted access, but I didn't give it.
Actually, I'm pretty sure that if you've got software and it tries to access a device in the container and it can't access it, if you have pre-existing software that does, it's probably going to complain. And if it doesn't complain visibly, then you could probably find it out using debugging tools of one sort or another. This was actually doing this was good because then it made it real clear exactly what devices were necessary as far as communicating with the Raspberry Pi. So
what happens if there are two containers that are trying to access the same device?
bad things.
Okay.
The same thing as if you had two different programs in the OS trying to access the same device.
Okay.
So
And these are standard device drivers in the Raspberry Pi, right?
Absolutely, yeah.
Okay.
Yeah, and the cool thing is that Linux makes most things accessible as a device, either a block device or a character device. And because of that, I'm able to do this mapping here. Also, note that in one case, I think I had one configuration where I had to remap both dev I2C0 and dev I2C1 in the container. I needed to put those both to dev I2C0 on the desktop, or I mean, sorry, on the actual Raspberry Pi, or things wouldn't work. It was interesting. It was literally the software I was using in the container was different than what the I would have had to do something like symbolic links on the file system otherwise on the actual host if I'd run the same software on the host. okay, I guess that doesn't, like, maybe I should describe it a different way. Basically, I ran across some vendor software that would only work if it accessed a particular device. However, the device mapping on the Raspberry Pi wasn't quite right. So I actually had to finagle it and swap devices around. So as far as other parts of this, volumes, here I'm actually making some data that's outside of the container accessible inside of it. I made a home directory for the ROS user that is actually just on the local disk on whatever system is running this container. And it's in the directory, it's in the PyCar Docker directory on the host system. The reason for this is to have a persistent area for data, since otherwise when you run a container and you get rid of it, any of the data or changes you made to it would go away. So the other and last part here is the commands user local bin deep sleep for running this container. So when this container starts up, this is exactly the one and only command that it runs. And I guess the question would be, what is in that command? And this is it. It just sleeps. Now, there's a couple other things that can go on here based on the Docker file. So this is the Docker file for this project. And I mentioned that there were an awful lot of images from different vendors available. So ROS does have images that they provide. And in this case, I decided to use, even though I'm no longer using, well, I am using ROS in some ways, but in some places, but I decided to use their image instead of building ROS from scratch myself. And they built this on top of an Ubuntu container. So when we take a closer look at this a little bit later, what you'll see is that each, when you could have 10 of these from statements in different files from different vendors, as each one of them built on top of each other. It would be incredibly inefficient to do it, but it could be done. And then you would literally, when you said, I want to use the latest one from this one that's nested 10 in, you would be downloading all of the different layers in each one of those different images and building that all up into one single running container. Now here's where the yak shaking starts. Setting up environment variables that are going to be used in the rest of the build. Debian front end equals non-interactive is what you want to do if you want to actually do all of your apt commands without any of them trying to prompt you, because Debian-based operating systems are designed to, for whatever reason, unless you give it essentially an answers file, to prompt every so often under some conditions during updates and say, oh, I noticed that you modified postfix's configuration file. So what do you want to do about it? It actually brings that up and prompts you. And this is a way to get out of doing that. And a lot of software actually needs the locales to be set up properly. So the first command in here that's an actual command in here is to set up a locale in the correct file in the operating system. Now, each one of these run commands generates a separate layer in the resulting container. Each layer is basically a tar file. So when you see someone run like a dozen commands or a very complex command in one run statement, you go, why would they do that? Well, that's because they want that entire set of commands to be treated as one layer. And in this case, doing an update of the available packages, installing one package or two packages that will keep things from blowing up later, doing an upgrade of all packages on the system, and then installing a whole bunch of utilities and a few things that are related to, for example, accessing the hardware down here, that are Python packages, all go into this one command, as well as the commands to clean up any disk space that we can possibly clean up to keep this image as small and this layer as small as possible.
Are these
So-
commands run every time a container starts?
No, they're run once when you build the container.
Okay.
So, they're also run in sequential order. There's no sort of out of order compilation in this. The execution proceeds directly down to the bottom of the file. And so the order becomes important. If you do things that have dependencies that would be later on, if you do them too early, things will break. That's another reason why you might see things like split up into pieces, is because they only make a sense at a certain point in the building of the file. Or it could just be the person just doing what they do. I mean,
The order is also really important for caching.
Yes, it's
That's
very.
the
I
number
wanted-
one thing.
Yeah, I want to give a little bit of an example of that where I do a build here in a few seconds. And the caching is like, it's like so obvious, like that's like 80 or 90% of your time is when you make a bad mistake with caching. And so a couple of other things here. Besides you seeing more and more environment variables and other things being set up, you see that there's an entry point file and it says set up the services that will run when the container starts. That is the other point where this incorporates pretty much, if there is complexity, this incorporates quite a bit of it. This was the original vendor code here that I put in there just so I could test. And what user this container is going to run as. If you don't specify something, you actually do want to specify something if you want to run as something besides root. And I do like to run containers as something besides root and only provide, say, pseudo privileges intentionally. So when you run a shell in the container, it's going to get dropped into the ROS user's home directory. And this combination here means that if you run an interactive container, it's going to run that entry point.sh, then it's going to start a bash shell. So behind each one of these commands is actually, they're mapped very directly into outcomes as far as what the layers in your caching look like. And the entry point in this one creates the VPN connection. And so if there isn't a tune device present yet, it creates a tune device. The fact that I enabled network capabilities for the container means that this has something to interact with outside the container. And OpenVPN runs here. Note, this is where in this setup, the configuration file for OpenVPN comes from the ROS user's home directory. So that isn't the case in the other containers that I'm running, but it is a choice. You have to choose basically for anything that has persistent data, you have to choose where you're going to put that data. Here are the choices, the user's home directory in the container for this particular piece of complexity or configuration, I should say. So that's basically it for, yes.
Can you say something about the caching? You mentioned caching a few
I'm
times.
about to do that.
Okay.
Let me, let's see.
All right, well, before then you get into the caching, can you speak a little bit to how you landed on having the VPN inside the container as opposed to like provided by the host, like having network provided by the host.
Oh, okay. So I wanted something that would work whether I ran it on my local system or whether I ran it in Kubernetes or wherever I ran it. So I figured, why don't I make sure that it's available in the Docker container?
Okay.
Yeah, so that's the entire reason.
Cool.
Yeah.
Okay, well, I'd like to follow up on that question a bit. Let's say I wanted to add just the VPN to my system.
Yeah.
Could I run your container, or it won't communicate with the rest of the stuff I'm doing?
Okay, so you've got two choices. One is you run my container with an OpenVPN configuration file I provide, because I sort of pre-generated a whole bunch of them for, no matter how many devices I have or we have, there can be unique OpenVPN configuration files that will receive unique IPs consistently on that OpenVPN network. So you could use that same file either in that container, or you could install OpenVPN on whatever device you want and use that file with it.
No, wait. I have my bot and it has its connection to Discord.
Yeah.
Is there any ways that I could run one of your containers in order to add functionality to my bots?
Yes.
What do I need to do? Okay,
Install
so
Docker.
I installed Docker, and now if I just run your container, I'll magically have a VPN connection.
As long as
How
you
does
put
that
that
work?
configuration, as long as you put the configuration file in the right place, then yes, you do. And that is because when the container starts, it runs this code right here.
I think the question might be then, like, can you get access to the network outside of the container, or do you have to put your code that's accessing the VPN inside this container?
Right, that's a question.
Yeah.
Okay, so recall that home ROS is mapped from outside the container. It's just a directory on disk on your host. So I can share the screen and you can see that. Let me share the shell. Mind you, I can't run PyCar Docker on my laptop, but it is running on the Raspberry Pi right now.
But you could run it if you had an emulation for the GPIO.
Yes, which would be a project in and of itself on.
No, I understand. I'm just saying.
Okay, so you see there's the PyCar Docker repo, and here's the home directory. And what would be in here would be an open make dir config and then openvpn.config. So if I actually go over to the PyCar,
You're not seeing that.
oh geez. Okay, so that even switching tabs in a shell actually stopped the sharing. All right.
Yeah, but bottom line, if I wanted to add my VPN, your VPN to my bot, do I have to do more than run your Docker on it?
Well, you need exactly one configuration file to do that. That's all.
No.
It's basically container plus one config file in the right location, which is home config client.ovpn.
Okay, so I'd be very interested in trying that out.
Cool. All right, then what I'll do is I'll share a VPN key on like Google Drive. And then you can just download it and try it out. I also should get you actually access to the you know,
Maybe a little bit more instruction, install this program and put this file over here.
right.
And we need some way of checking that we're actually on the network.
Yes,
Is your
Yeah.
network running all the time?
yes.
Okay.
Yeah, it's persistent. And you'll get a unique IP on it, and you'll be able to ping the gateway on it as well.
And this should work for anybody who has an ARM system, basically Raspberry Pi.
Well, yeah, and I could rebuild the image or make an image available that would work on any x86 system too.
Okay, so let me flip the question. Could
Yeah.
I take my Discord interface and make it into a Docker image, which would run on yours?
Almost certainly.
Another, again, as an add-on. In other
As an
words,
add- Well, one of the things about Docker images is that they're usually relatively specialized. So like I might have one Docker file to do one particular thing, like talk to my Raspberry Pi, and then
Mhm.
I would have a different one for a different purpose. And I'd actually kind of have a repertoire, or a bunch of these built up for different purposes. This is on the server side stuff that tends to be used a lot in, say, microservices and things like that, where you have one thing running in each container, or many different
Right.
many containers running the same image, or things like that.
What
But-
happens if two containers get into some sort of contention? Like two containers both assume they have control over the camera and both are trying to do something
Yeah.
with the camera.
So it would be the same, because it's really not the container in that case. It's actually the programs that are running in the container. And so it would be since it's still basically mapping to Linux devices, it would have the same results as having two different programs on your desktop or your whatever, on your Pi, directly trying to access those same devices.
Which sort of boils down to how those devices are designed to work. A lot of
Yeah.
them, if they're operating just like they open like a file, and if you try to open it up and someone already has it open, it will like fail to open. Or sometimes you can have multiple programs accessing the same device and it's fine.
Right.
But
Or
it depends on the device.
Yeah, or you hope for the best, because, for example, there's some ways that, for example, you could share block devices on a network, for example, and
you
then
shouldn't.
have two people access them at the same time. In which case, both of the programs, or typically both of the programs that are trying to access those block devices, have no knowledge of each other, and they're trying to write to a complex file system. And the file system isn't doing any locking of data whatsoever. So the two, basically that data gets overwritten and corrupted very quickly by these two different programs accessing it and trying to write what they think is the right thing. It breaks very, very quickly. So in our case, I'm not too worried about that sort of thing happening here. I think that hopefully, like in this case, on my deployment, I just have one container running, doing all of the things on the Raspberry Pi. Kubernetes infrastructure, I think I have a couple of containers up right now in different namespaces, but they're not trying to do the same thing. So I'm okay there. So let's see here. What exactly am I sharing at the moment? Okay, so okay, not this one. I'm going to stop sharing and go over to and show a little bit about building things and so on quickly. All right. Okay, so this is the more complex environment with the less complex way of building things that I have for running something that's very unusual by Docker standards. Like, remember I mentioned it's normally used to run one application. Well, here, it runs a full desktop environment. And it's custom built, and it's a little bit just to see what that would look like. The custom environment is accessible over VNC, and that would be tunneled VNC if this was running on Kubernetes. So it'd be actually secured. Now, I don't think we are going to go into all of the complexity of this thing, but you can see like it has stuff related to the VNC server, and that instead of having the home directory be where the VPN client information is stored, it's actually stored in a particular mount point from a volume. And that down here, get Anaconda Python, and this will deterministically.
Okay, just a second, Victor. So sorry for interrupting. So here I have to ask, if I run this Docker image, will it give you over your VPN VNC access to my Pi?
So this isn't really intended to be run on a Pi. It's a really heavyweight. There's stuff in here that's a bunch of Node apps and Java apps and Gazebo and things like that. And so when I run it in, say, Kubernetes, I'm running it on something that has like a minimum of 8 gigs of RAM. So it's a big desktop environment that just so happens to be in a container. Like you can see, like there's Visual Studio Code, Anaconda Python, Gazebo, Capella Sim, OpenMCT, then a custom Windows theme, icon, background image. The PyCar code just for fun. And then it runs a whole bunch of services to make all this work right. So this is a big piece of gear for a container, or for at least for a Docker container.
My Pi has 2 gigs of RAM. I think it might work.
Yeah. Well, right up until you run Gazebo.
Yeah. Okay.
So some of the other stuff will be fine.
Man, I had to run a Super Nintendo emulator, not Gazebo.
Yeah. Let's put it this way: when I run it on my laptop, the fans ramp all the way up.
So what are you using this base, GoNC Mars base for?
I use it to basically get a deterministic way to install all of the software that either I or other people kind of thought were interesting earlier in the project and make a desktop environment with it. Now, the good thing is it deterministically installs all those things. They work the same every time, and there's like no difficulty, for example, getting Anaconda Python to work right. And the same stuff that I already have there, I could port it over to, I could literally copy and paste the commands in Ubuntu 2004 and it would work. So it's sort of a both documentation and a way to just kind of test out different approaches and see how far you can take them.
If I try to run this on my Windows machine, it should be running without problems.
It should actually work.
Okay.
Yeah, it is. That part of it is operating system agnostic. Now I'm building this image. And here's where the caching comes in. Can everybody see that? So what Rhett was mentioning earlier was that caching was very important. And you see, for many of those run commands and copy commands and so on, the results were already cached. And so I didn't have to, this build didn't have to do anything. And the entire build finished in, several seconds. We're done. That's pretty nice. Now, let's say, where would I put it? that. You see, it ran every command after, starting from the one I modified, it ran every command after that in the file. Those are all still pretty low impact commands. They didn't take much time because they're like copying files and things like that. Now, so now it's taking more time because it's having to clone stuff from a repository. I can tell you that if I changed the first run command in this entire stanza, then this build would take approximately 30 minutes to build from scratch. It builds the entire operating system and downloads every single piece of software, and doing things like installing Anaconda Python and so on. And so that's why the caching ends up being important. It also ends up being important that each one of these layers be as small as possible, because let's say I make one of these layers inefficiently, like I don't clear up any caches that it creates or something like that. That ends up being in that layer, and it balloons the size of these images pretty quickly. So many of the things with this have to do with playing with resources and time and space. Like it really is nice when the build's finished real quickly. It is much better for developments. So, yeah.
So I don't understand something. How can you cache a Git? Because when you pull, you don't know what version you're going to get.
So
it might have been updated.
Right. So this thing actually kind of makes some assumptions, and it's not great because of that. Like if you see, I think up here, you can see apt-get update and install. This one, the rest of this command actually doesn't apt-get dist upgrade. It's kind of important to keep your stuff up to date. So regenerating the whole image from scratch every so often is also a very good idea, especially for security related purposes. If you're doing this in production, you'd be keeping really close track of that, and hopefully, and you might be deploying specific, instead of deploying the latest image all the time, you might be deploying very specific images. Like you might be deploying a specific release of this image instead of the latest version of it or something like that. I'm going to switch over to the PyCar. So actually had it up for a little bit over 2 hours. I think it's got some more hours of battery time left, so we're good. The only thing I'm going to do here is enter that already running container. So the container fired up when the system booted. And this is actually not the, this amount of storage space here is the amount of storage space on the entire, SD card that I've got. It's not the space inside the container. The container is part of an overlay file system, so you still see the same amount of space in theory, but they're in practice coming from a couple of different locations. So here's some code that uses ROS. Just a little bit to publish the values from the light sensors on the bumper on the Pi car. And you can see direct hardware access there. And publishing an array of light information. So if I can get the robot enough in front of me, you can probably see it. This here is the bumper. And what's on there is some resistors to set the sort of what actually ends up getting reported back to the Pi car about the value on the phototransistors that are being used for sensors. And those are the light values. Higher is less light. Here's my flashlight. And you can see I just started shining that light on one of the transistors on one side. Go to the middle, and I go to the other side. So this is what this thing uses when I have it chase a flashlight around, which I don't really do too much anymore since the Pi car itself is getting kind of fragile. Now, since this is on the VPN, when I go over to and fire up the subscriber to this in Kubernetes, then it will actually show up there. And since I've already got a running pod, what I just did now was I got a shell on inside of that pod. So there's the same repository there. This is in DigitalOcean's cloud. So the first one was running on the Raspberry Pi, sitting right next to me on my desk. This is running somewhere in DigitalOcean. And it's working.
So this is over the VPN, the Kubernetes instance of the container is listening to the event stream from the Pi car. Is that what's happening here?
That's correct.
Yeah.
All the network traffic is over the VPN.
What's the delay?
It's as bad as my network connection. So since I think I mentioned my network connection is not the most amazing thing in the world. But if I say switch now, so as far as human perception, it's pretty much like dead on.
So it's less than a second.
It's far less than a second.
Okay.
If you're if you notice, like if I type a shell command in the Kubernetes stuff, I don't think you can. You're in Israel, but I don't see any delay over here. So my network connection is typically better than human perception, but far worse than machines can do.
So
yeah, but you might be on the edge instead of on the cloud. In other
Yes,
words, when you say DigitalOcean cloud, but you might be right next to the edge.
I think the servers are a bit of a distance from me. I'm not in Silicon Valley or anywhere important.
So what is running in the DigitalOcean? I didn't understand.
Oh, it is a subscriber to the
So it's just a Python script.
yeah, just a tiny
Right.
Python script.
And this is connected to the Pi car via VPN.
Yeah.
Okay.
And what's happening inside there is there's also a network layer that is handled entirely by ROS itself. basically. So it uses RTPS as an algorithm for trying, or it is a protocol for trying to figure out where the other nodes are and communicate with them. And it does so in a way that can be encrypted and made relatively secure. It isn't, I think I mentioned previously that some of that's pretty old school as far as the actual technology, but it does work. And you can see this is actually pretty simple for getting the publisher and subscriber set up. It's not overly complex when you look at it like that. Once you start having to build packages in ROS and things like that is where it gets a bit more complex.
Did you have to do anything special to make the ROS network work over the VPN, or just?
Well, I was having trouble initially so one thing about OpenVPN is it doesn't support multicast. So ROS 2 relies on multicast, but not really. There's it'll do broadcast just fine.
Now you sound like the documentation.
Oh, the documentation for yes. So it will also, if it can't do multicast, it will do broadcast. And if you follow this incredibly esoteric configuration file format, which is not correctly documented, like the best examples of it are incorrect, then it will also go out and try to talk to specific IPs. And I've tried it both ways. And I found out that to try and talk to, for my use cases here, to try and talk to specific IPs wasn't actually better than just using broadcast, which is still, I mean, it's really inefficient. But I was also thinking about setting up a multicast router inside of my OpenVPN network and trying to handle things that way. But that's some pretty complex stuff, and I wasn't sure I wanted to maintain it.
And I have a question similar to the one below. So I have on my Rover, I don't have ROS, and I don't have ROS 2, but I do have a logging program which continuously measures the sensors and stores them somewhere. If I wanted to broadcast them on the OpenVPN, so in order to get to OpenVPN, I installed one Docker image. We talked about it.
Yeah.
What do I need to do in order to export the information from my Rover with the minimum amount of changing of my software?
If you want to talk to Ross, or if you just want to get the information somewhere else.
Oh, I want a Docker image which will have all of your ROS magic. And it will, I'll send it the information in some standard way. Okay. And it will broadcast it on the network.
Well, that should be pretty simple to do. And this, you saw that like a subscriber and a publisher were both pretty simple, right?
Yeah.
So as soon as there's anything that can read from any data source in that ROS program, then that information can be published verbatim. And then it can be read somewhere else.
So basically what I need is a Docker image which has in it ROS 2 and some basic type of communication protocol.
Well,
like
some basic
file.
Yeah, it literally, if you put a file in there, there could be some code in that ROS file that would just keep trying to read new lines from that file and then publish them whenever they showed up.
So is it possible to build a Docker image, which when I run it on my computer, gets as a parameter the name of the file that it's supposed to publish lines from?
So Docker will accept input from environment variables and from other sources where you can specify the file name. You could hard code it if you felt like it, but there's ways to provide information to a Docker container when it starts up about what it should be doing after that. Like I think I mentioned, I didn't go into it in much detail, but I think I mentioned somewhere in the comments in one of the or both of the Docker files that if I was doing this in production, I would be passing this information in instead of hard coding it in the Docker file.
Okay, so in addition to trying out open VPN connection, I think it would be very interesting if I could publish my log data, not the images maybe, but sensor readings using a different Docker image.
Okay, all right, I'm totally up for that. I'd be happy to kind of help build it and get it going.
So the communication protocol that ROS uses is like pretty strongly typed, right? Like you saw even in the output of that, it was like an array of integers, and here's the 3 integers.
Yes.
I wonder what kind of protocol you could build that'd be a little bit more, I don't know, arbitrary, that would allow other programs to plug into it easily.
Yeah, it does
That might be.
have some data types are a little bit flexible, but they're not that flexible. You're right. In my cases, I was like, okay, fine, you know, it's easy enough for me to treat everything as an integer or a string and be done with it. But it doesn't support, it supports a lot of really basic data types.
I mean, I guess if you could just do a string blob, that should
I think
work for
that's
just
what
about everybody,
maybe
right?
a lot of people are doing is they basically just
JSON.
yeah, you just incorporate more complex structure within strings and then decode it on the other side.
So I'm still struggling a little bit with why you would use Docker at all, rather than just run native on the OS. And the best reason I can come up with is actually code sharing. Like in this particular case, it's like if you're writing a module and I want it to run on my robot, then you basically give me your code with the sort of environment it needs to run in, right? So that's not quite the use case that you originally mentioned of it runs on my laptop and not. So that's like you're managing multiple environments in sort of a development pipeline, as opposed to you're managing multiple environments in a large collaborating team. Because if it's just one person and I have like, a cloud server and a robot and maybe a laptop, I can kind of like get away without doing any of this and just use the native environments, right? But as we add more people and more people writing software, is that when the value really starts becoming clear?
The value starts at the point where you want to come back to something that works. Like I have maybe 3 or 4, like I have 3 different SD cards for this Pi car with different operating systems on them. And so if I want to not have to reinvent the wheel with like on the Raspberry, the Raspbian version of this, you have to compile ROS from scratch on there. So I want, I do enough experimentation where I wanted to make sure that I had some way of not having to rebuild everything from scratch every time I did something. I did something new, and Docker's a good way to do that, as long as Docker itself runs on everything, and it's pretty good at that. So it was one layer of abstraction that allowed me to not worry too much about other details. It also kept me in the habit of not just building everything by hand. Like the first setup I did for when I was doing the iteration one there, I was like, okay, I'll just build this up from scratch. And so I have a Jupyter Hub instance running where to reproduce it, I would have to look back at a set of notes and kind of hope that I get it right. Whereas if I'm using Docker and I want to go back and do something, I've actually got a Docker image and a Docker file that actually works. and will probably continue to work for something close to the lifetime of the software involved. Yeah.
All right, you got it. I'm just wondering, I think because space programs and fleets of rovers with remote deploy of code are much older than containerized virtualization, right? So I'm like wondering how this evolved in space programs, like all the way from like Pioneer 10 through the Voyagers through the modern rovers. And I don't think even now the latest generation of rovers are still not at virtualization, right? They're like still pretty much bare metal stuff.
Yeah, and so the thing is, I was going to mention this sort of towards the end, like, or as an aside, but if the question is this new? And the answer is no. And the other question is this something that you need and you can't find some other approach to do it? And the answer is also no to that. The fundamental underlying issues are the things that people actually care about, like, will my code run? And Docker is a way to address that basically says, fine, well, we know this probably depends on an operating system, so we're going to drag an operating system around with our program just to make sure it works everywhere. There are other ways to do that. And one of the reasons I want to have, like, I guess the last kind of slide in here was sort of a discussion on this, because Docker itself would be, it doesn't match all use cases. It doesn't match firmware deployments, for example. And it is also a lot of overhead to pull a full operating system around whenever you do something. So if you can write your own custom approaches to this. Before Docker came along, I had my own custom approaches. And they were actually lower overhead than Docker is, but they're also custom, and I wrote them, and that's it. That's the end of it. Maybe a few other people use them in environments that I'm in, but they were just for a matter of convenience. And getting someone else to use something that only you use is not necessarily a good idea. It's better in a shared, especially in a shared environment, that there be some sort of shared language and context and tooling. So, like, I guess my general question is like, how are people doing this themselves, or how do you intend to do it? Like, Docker gives you a certain tempo to the approach naturally. Like, building the entire image over again is something you typically do. You edit the Docker file, then you build it. You edit, then you build. That's your cycle. Maybe, at some point you push. And the artifact is always pretty close to, it's let's just call it reproducible. Your results are reproducible. Other approaches, edit, commit to Git, pull somewhere else, run it somewhere else. Then there's over-the-air firmware updates and things like that. But the general questions here is like, what are people doing, and what is the natural tempo for that approach that they're using? And does it have these other characteristics like version control and backups and so on? And does it blow up? Does anybody have kind of any ideas or input or anything like that, or even aspirations, like it would be cool if type of things?
I can talk about my experiences a little bit, because I've got kind of two very distinct ones going on right now. And one of them is that bare metal Arduino programming, which you are pretty much tied to a USB cable, unless you get into more exotic, I guess, more modern versions of Arduinos that maybe they can program over Bluetooth. I don't know what they're doing, but on just a straight Arduino, you plug it into the USB and you like run your IDE, and it like flashes the memory and you're there. And that's a pretty tedious workflow. I have gotten a lot of improvements by switching over to whatever that plugin that Anuraj was teaching us about.
Platform IO.
Yes, Platform IO. Platform IO is great, and that I can at least use VS Code, but you're still programming your Arduino directly via USB cable. But you're kind of stuck with it. But so since I started working on Raspberry Pi for more ground station work, I actually thought about containerization for a minute. And then I realized that it's a ground station. It's not actually moving. So it's a little bit different than a rover. I actually just connect using VS Code and develop directly on the Raspberry Pi over SSH. And I actually did that on vacation and it worked flawlessly. Like I couldn't even tell it was a remote machine, except it died once. And I had to have some helping hands reboot it for me. But that worked great. But then I'm also checking everything into GitHub. So it's not like, and I don't have a lot of dependencies or a complex environment for that particular project. But I can easily see how that ceases to be the case. And suddenly you're like, oh, I don't remember what command I ran to install this obscure Python library that has to be installed somewhere. Yeah, I don't know. It can get complicated really fast to where I can see this being a problem.
Yeah, so like, for example, could I, if I wanted to use your software, would I be able to just do it on, say, like, are you using Raspbian or using like Ubuntu or?
Yeah, so I think I left it as Ubuntu because that's what I was doing my ROS testing on. And so that's the last operating system that I had installed on it. But the software itself is pretty it's like what I'm working on is not using all those dependencies, and really it's just using Circuit Python, which was not too difficult to install, but I took notes. I don't know. That would probably be much better as a container image for sure.
Yeah. Yeah, well, I guess that's kind of
yeah, I can just sit 10 seconds on what I'm planning to do. This would be, I think, beyond my capabilities this year. So I'm planning to do the absolute minimum of, there's a BeagleBone robotics library with sample code. And I plan to fork a version, add my own code to it, and just pull it to the board and run it, compile and run it there. I don't plan to do anything more than the minimum necessary to turn a motor on and off. So I think it'll be enough of a challenge getting there. But I can see, yeah, if I wanted to go to the next level and open it up so the rest of you can use it or something like containers and I'm thinking of it mainly from a safety perspective, having a fairly safe bundle that runs as opposed to raw access to the system. So yeah, for next year, I'll probably go towards this level of sophistication. But for this year, no.
Yeah.
Have you tried to remotely drive the Pi car from the cloud?
Well, I actually, pretty early on, I actually was doing it not as teleoperation, but as completely autonomous, and it worked. It was not a very sophisticated algorithm, like when Eric was mentioning about how the basic approach is kind of drive forward until you see an obstacle and then you make a decision to go one way or the other way. Yeah, that was the level of the code. It was not sophisticated at all, and it's like, oh yeah, I detected something right in front of me, stop. 50% chance turn one way, 50% chance turn the other way, back up, and then turn one way or the other way. Yeah, it was cloud driven there for a while. I think teleoperation would be cool, but I haven't played with it yet.
Okay.
Yeah. Well, it's good to see people's different approaches on this. I'm going to continue to do more with this, primarily because it just makes things easier for me and I already have it. I was looking on Docker Hub at like how many times I've downloaded the different images, and the PyCar image I've downloaded it like 40 times, and the yeah, and the desktop, essentially the desktop environment, I've got 189 downloads, so I have been using it, and I'll continue to do it because it means I don't have to worry too much about that layer of things. The hardware is much harder in my case. I'm sort of the opposite of Venkatesh, building from the the very bottom up. I'm kind of having to go from the top down in terms of the so if you consider software the top of the stack as opposed to the bottom of the stack, depending on how you're looking at it.
Great. So forget who's it. Oh, next week is the special session with Eric's guests. So yeah, and I think after that it's you, Mayor. So all right, and don't forget to fill out
I have a question.
Yeah.
I've been putting up recordings. Has anybody looked at the recording? I'm putting it all up on the YouTube channel of the Yak Collective.
I haven't, but I was planning to tweet them at some point from the account and promote them when we are closer to our own event and stuff.
I checked them, but there wasn't any name conflict with other channels.
Yeah, can you post a URL?
Yeah.
Whatever Yak Collective is.
No, there is already a channel called the Yak Collective, but it's something like they are going to Mongolia or something. A traveling blog or something.
Okay, but I'll do that. It will take a few days, Victor, for yours to go up.
Okay.
Because I'm not near my computer.
Yeah, I think we're just at this point building up the content and the channel, and in fall we'll I think make some decisions on how to leverage it.
Yeah, but it's not edited. It's not edited.
I think that's fine. Like something is better than nothing, and unedited now is better than like beautifully edited never, right? So because that often happens. Like with blogging, that's what I discovered. Like the more you have ambitions for polishing stuff, the greater the chances that it'll never go out at all. So video is just worse because the tool chain is so much heavier. All right, so don't forget to do your weekly update. Link is in the calendar invite, by the way, in case you didn't know. All right, so next week, special guests. See you guys.